Welcome to the Stanford Microfluidics Lab. In the next couple of videos, we'll introduce you to preparing and performing experiments in isotachophoresis, or ITP. This is video 1, where we will present a simple ITP experiment with typical chemistry for the leading electrolyte, or Le, and trailing electrolyte, the Te. We will also visualize the ITP peak by introducing fluorescein in the Te. This series of videos on ITP and the supplementary document contain the following 5 modules. The current video covers the preparation of ITP buffers. We assume that you are familiar with the working principles of ITP. If not, we recommend you check out our group's Journal of Visual Experiments ITP tutorial and our in-depth ITP review in Chemical Reviews to be published in 2022. In this tutorial, we chose standard ITP buffers, but we encourage you to evaluate alternative buffers using our web-based ITP simulator, CAFES. These 3 resources are linked in the supplementary document. So let's prepare our Te and Le buffers, and we'll begin by preparing the stock solutions. These are high concentration, aqueous solutions of individual reagents which will be added to all our buffers. First, collect tris, heaps, and PVP powders from the flammables cabinet number 1 in 218. Find the 12 molar liquid HCl in the acid cabinet below the fume hood in 218. Collect DI water in a glass beaker from the right-hand faucet in any of the sinks. Collect serological pipettes and the motorized pipette filler from the overhead cabinets above the AB thermocycler in 218. Collect 50 milliliter Falcon tubes in the overhead cabinets left of the motorized microscope in 218A. You should now have all of these materials together. Use our lab's AccuLab weight scale near the PDMS workstation. Grab a weighing boat and spatula from the shelves above. Place it on the scale and tare the scale. That is, zero it. Measure out 4.8 grams of tris powder. Pour the measured tris powder into an empty Falcon tube. Then use the motorized pipette puller to introduce 40 milliliters of deionized water. Rinse the spatula to get the rest of the powder. This will create a 1 molar stock solution of tris. Seal and shake the tube to dissolve the powder and label the tube appropriately. Repeat this process for the heaps and PVP powders. The HCl stock preparation is slightly different, since HCl is sold in liquid form at about 12 molar concentration. Add 3.3 milliliters of HCl acid to 36.7 milliliters of deionized water. Don't forget to label the tube. We have now prepared the necessary stock solutions. Make sure to return all materials to where you found them. These stock solutions will be useful for the next steps when we prepare the Te and Le solutions. Now, for the first time in this tutorial, we will use pipettes. Therefore, we strongly recommend you check out the pipette tutorial linked in the supplementary document. We are interested in achieving the following Te concentrations. If we want to make a 10 milliliter solution, how much of each stock solution do we need to add? Think of it this way. The number of moles we put in must equal the number of moles in the final 10 milliliter volume. We know we want 100 millimolar tris in a 10 milliliter volume. We also know the tris stock is at 1 molar. Therefore, we need to add 1 milliliter of the tris stock. At these concentrations, we can assume conservation of volume. Hence, we sum the stock solution volumes, and we see that we are not quite at 10 milliliters of Te and Le. Therefore, we add DI water to this volume. Now let's prepare these solutions. You'll find a big collection of pipettes in the island counter in front of the entrance to 218. Make sure you have P200 and P1000 pipettes. Find pipette tips in the overhead cabinets to the right of the AB thermocycler in 218. The boxes are usually labeled by the tip volume. Find pH strips in the pH strips shelf in 218 across the AB thermocycler. Select strips rated for pH values between 5 and 10. You should now have all your materials ready. Add the necessary volumes for the Te solution into a Falcon tube. shake, and label appropriately. Repeat this process for the LE solution. We can measure the pH of the solution by aliquoting about 40 microliters of the TE or LE solution onto the detection region of a pH strip. Compare the color of the pads to those indicated on the box. TE and LE should have respective pH values of 8.5 and 8.0. We're done. Proceed to video 2 to learn how to load a chip in preparation of an ITP experiment.